Okay, so C and B are related because now C wants to know the number of hydrogen atoms. And just like we've seen before, molecules, atoms, number of whatever it is can be interchangeable or converted to moles with our Avogadro's number. Okay? So that's the idea here, because we know moles, and we know this because that's just a constant, so that'll help us get the number of total hydrogens, because this is just moles. Again, 1 dozen of donuts, like, it implies 12, you know? So that's kind of the same thing here. 0.5 moles of hydrogen already tells us the number of molecules. It's just a different number. Do you know what I mean? So when I say we have a dozen donuts, you already know we have 12. But that's just because 12 is an easy number, dozen, and moles is like a weirdly large, confusing number to do mentally in mental math. So yeah, but that's like kind of the logic to work with. So again, write what we know, or what they give us in the question, I guess. So from previous, we know that we have this. Moles of H. Again, our fraction. What do we want to cancel out? We want to cancel out moles and get to molecules, or number of. So we can just say total H, I guess. So those cancel out and we'll be left with total H. That's good. So, in 1 mole of H, how many total H do we have? That's where we use this ratio. And I can see someone getting confused by like, oh, how do I know if I put 6.02 on the top or the bottom? Well, you kind of have to think, do we have 6 times 23 moles? No, we have to look at our question of hydrogen. We only had like 0.5 moles of hydrogen, right? So this is what I'm talking about, like, of doing it with fractions, because if we were just inputting raw numbers into our calculator, like, personally, I could just as easy multiply by 6.02 or divide it, you know? So this will help you. So yeah, we have mole of H. We want to get rid of mole of H. Yeah. Again, you'll just practice it. And honestly, in context, like, you can kind of, you see, like, the first thing, we kind of expected a small amount of moles. So if you got, like, a crazy big number, like, I don't know, the question 2, like, this, whatever, like, the 9 billion gazillion, that one was kind of weird, and that's why I kind of wish you had an answer key, because that's just a strangely large number. Even though I think my math is right, it's just weird. Anyway, yeah, just know your relationships, moles and molecules. And, yeah, sorry, that was just a long-winded way of saying keep track of your numbers, I guess. So, that many moles times 6.02 times 10 to the 23. So we should have a lot of hydrogens, which makes sense, because we do. 5 times 10 to the 23 total hydrogens. Oh yeah, I don't know if your questions want you to round properly. I have not been rounding, but yeah, if you need help with rounding, then you can let me know. Okay, yeah, that's how you do that one. Yeah, again, use your fractions, know your relationships. Yeah, we had molecules to moles, and moles to mass. So this relationship is, that's how you go from there to there. And to go from moles to mass, we use our molar mass. So this is a constant. This number won't change. This number you have to calculate each time. Yeah, so once you know these things and the fractions, I think it'll help you out.